This video will explain how to test an equation for symmetry about the axes and the origin. To check for x-axis symmetry, we'll take the original equation and replace the y with a negative y. For y-axis symmetry, we'll replace the x with a negative x. And to check for origin symmetry, we'll replace both the x and y in the original equation with negative x and negative y. Once we've made the replacements, we'll manipulate the equation a little bit and see what we get. If we get the original equation back, then the symmetry is confirmed. If we do not get the original equation back, the symmetry might be there, but we can't confirm it algebraically. Those are maybes. We can confirm, but we cannot deny the existence of that type of symmetry through algebra. For these types of problems, usually the instructions are to identify which types of symmetry exist, and then you're given a list of the 3 types and a none of the above, and you check the ones that work. We're going to look at 4 examples. Here's our first one. To check for x-axis symmetry, again, we're going to replace the y with a negative y. So you'll see here there's the original equation, and I replaced the y with a negative y. Now we could stop there because clearly those two are not the same equation, but if we want to solve it for y, just for parallel's sake, there's it solved for y. We did not get our original back, so this is a maybe, because while my y is positive, my 7x and 4 are both negative there, and they are positive in our original equation. To test for y-axis symmetry, we're going to replace the x with a negative x. So there's my original and the replacement. When I work it a little bit, there's the final answer. And so this is also a maybe because in the original the 7 is positive. Lastly, for origin symmetry, here we're going to replace both the x and y with a negative x and a negative y. Here's my original and the replacement. Messing around with it a little bit, manipulating it, I plugged in my negative x, and then I can multiply the whole thing through by a -1 to get the y to be positive. And this is a maybe also because we did not get the original back because this is a -4 and the original is a +4. Let's look at another one. To test this for x-axis symmetry, we'll replace the y with a negative y. And then here, if I want to solve it for y, just so the y could be positive, there would be my final answer. Notice it is not the same as my original, so that would be a maybe. Testing for y-axis symmetry, we'll replace the x with a negative x. Remember, when I raise a negative number to an even power, it becomes positive. And there, I did get my original back. So this equation does have y-axis symmetry for sure. It might have x-axis, but it definitely has y. To test for origin symmetry, we're replacing both the x and the y. And then I'll manipulate the equation a little bit, solve it for y, and then this is also a maybe because my signs are not correct. 2 more examples. To test for x-axis symmetry, we're replacing the y with a negative y. And so this is a maybe because the original is a negative 5x cubed and our negative is gone. It's a positive now. To test for y-axis symmetry, we're replacing the x with a negative x. Remember, when we have a negative number and we raise it to an odd power, our answer is negative. So that's going to make that whole thing positive. And again, this is a maybe because we're missing the negative sign from our original equation. Last, checking for origin symmetry, we replace both the x and the y. Manipulating, and then solving for y here, we do get our original back, so that's a yes. Last one. For x-axis symmetry, again, we're going to replace the y with a negative y. When we raise a negative value to an even power, we get a positive answer. So we got our original guy back, and that's a yes. For x-axis symmetry, we replace the x with a negative x. When we raise a negative thing to an even power, we get a positive, and we got our original guy back. Lastly, for origin, we replace both the x and the y with negatives. Again, we have negative values raised to even powers, which makes them positive, and we got our original back. So this one is a yes for all three. I hope you found this helpful.